Please join me as I make welcome Ukeme David. He's going to be talking on field notes from the trenches. A round of applause for Ukeme David, please. Thank you.
Oh, hi guys, hi everyone. I'm so sure you're tired. Yeah, but I'm going to talk about something really interesting that people actually don't talk about in the Web3 space. I'll start by asking a question. So your software, your smart contracts, everything you're doing in terms of software, where do you think it runs on? What do you think makes it work? Anybody? EVM. Okay, so what is holding the EVM? A what? A remote server. So a remote server is what I'm going to talk about today. The infrastructure side of blockchain that nobody talks about, and the DevOps side of things, right? So, is this coming up? Okay, so that's going to take a while. So what I'm going to tell you is, for the blockchain to run, there is a backbone, a very important aspect, which is the infrastructure. The EVM is not really a machine. VM meaning virtual machine. The EVM is not a machine. It's actually a software that runs on a virtual machine. And there are two options for this machine. It's either your machine is on-prem, meaning in a real place where you can physically go there and touch your machines, servers and all of that, or it's going to be in the cloud. So when we say the cloud, it's not actually in the cloud. Can I get this thing running? Because my 10 minutes have started. Right? So now, on-prem is when you have bare metal machines and then you set it up, your software, ZK, everything eventually becomes a binary. For us, DevOps engineers, that's the end product of the code you're writing. It's just a binary for us. So we then take that binary and then try and configure it in a fleet of nodes. At the moment, we handle more than 5,000 nodes. That's what actually makes your blockchain run. 5,000 nodes. Some of these nodes are remote. People run them on-prem. Some people run them on the cloud. I want this thing up, please. If someone can come and check. A fleet. A fleet meaning like a set of nodes, right? By nodes, I mean machines, right? So my slides are not coming up. So I have some very interesting diagrams that shows the layers of the infrastructure parts of blockchain, of the entire thing. So there's the layers. It starts from the application layer, which is actually where your smart contracts runs, the dApps, the UIs. Then we have the consensus layer. The consensus basically, when you hear consensus, is basically a node, is a machine running a node that does the computation, right? Do you get? We say consensus algorithm in blockchain. I hope that's not big grammar because we are all technical people here. That consensus algorithm is actually running on a client that is running on a dedicated server. I actually want to show you how it looks. Yeah, so when we want to create a blockchain network, right, you can't just create any network, right? You need to have a specific amount of nodes you would deploy, right? And there's a formula for that. Just so to keep that high resilience, right? So if one node goes down, the other node is still running the consensus or the validator, right? So there's something called 2F plus 1. 2F plus 1 is the small formula that we use to define the amount of nodes that should run in a network. The F there, right, actually means Byzantine nodes. So when you start learning blockchain, they talk about consensus mechanism and those things, and you hear them mention Byzantine nodes. And I didn't know about that up until I started going deep into the node part of things. So those Byzantine nodes are actually designed to, in case anything happens or something fails, the system can still, all the networks, all the nodes can still connect and, interact and share blocks, right? Or record blocks. This is crazy. Oh my God. Do you know where my slides are? I wanted to show you guys some very nice images and how. Okay. It's not even. Let me see. Anyways, let's just use our imagination and try and just continue. So 2F plus 1 is what you use to define the amount of nodes that should be in a network. The F there actually represents Byzantine nodes. So in a network of 7, let's say in a network of 7 nodes, right? It means 3 is actually your original node. 3 is a Byzantine node plus 1, which is also the Byzantine, one of the Byzantine nodes to allow that resilience so the network doesn't go down, right? So I want to deploy my machines. How do I deploy them? That's where you need to use cloud or DevOps tools, right? Any cloud engineer here, any DevOps guy here, nobody. So you see why, okay, I know him, he's my guy. He's from one of the AWS people. Yes, so you see why if you come into the DevOps space in blockchain and you niche, you actually make a lot of money. Because I can count how many people who are DevOps engineers in blockchain here. So moving forward, how do I deploy these machines? We use infrastructure as code, right? Something called Terraform. So I can just write some code and then tell this code, I want to deploy 7 machines, right? It's going to write the code, deploy it, the instance type, everything. Once that is up there, right? We can now start talking about RPC nodes. What is an RPC node? So an RPC node is what runs that RPC protocol that actually connects the outside world to your validator nodes. Do you understand? So I make a request, I want to make a transaction. That transaction goes straight to the execution node, which is the execution client. That execution client sends data to the validator. Validator does the computation, sends it to the consensus sends it back to you, right? So that's kind of like how it works. I wish I could see a diagram there, but this is so unfortunate, but it's fine, right? So you need, in a network of 7 validator nodes, you need 2 RPC nodes, at least 2. Why? You need one of those RPC nodes to run your faucet requests. So if I want to request faucet or some tokens for that network, that RPC node is going to handle it. Then you need another RPC node to handle every other request in terms of like the validator requests and execution requests and all of that. So the question now is, what makes the blockchain network highly available and sustainable? So if one node goes down, I don't have issues with any of my transactions. Everything is still working, right? This is when networking comes in and DevOps part of things. There's something called HA proxy. HA proxy. Oh my God. No. Well, it's fine. HA HA proxy actually stands for high availability proxy, right? So once you make a request for a specific transaction, it goes to the HA proxy. HA proxy handles all the loads, right? And it tries to balance and distribute all the transactions or requests to different validator nodes. Time's up. Do you get? So that's kind of like the entire jerk. That's kind of like the entire gist. I advise people to go into blockchain for DevOps because there's less competition and it's actually very, very interesting. And you be the one handling, managing the servers, deploying the servers, configuring the servers. Imagine managing 1,000 fleet of nodes for Solana. Just imagine that kind of thing, right? If it goes down, it's you. If it doesn't, it's still you. You work on the architecture and all of that. So that's pretty much it. Thank you so much for your time. I'll post my slides online. Thank you.